This video finishes up our Chapter 6 examples for business finance. So we have information about, this is an example of what bond sales look like. So this is actually the table out of your textbook, so table 6.3. It's condensed, it's not as big as the table in your textbook, but you can see what information you need for your homework assignments on it. The table in your textbook is on page 189 in the 10th edition. So what it wants to know is we want to locate the Treasury issue maturing February 2029 and then fill in all of this information for it. So first we need to find the one in 2029. And there's only one, and it's this row here. So we can highlight that so we keep it up. So we have a lot of different information on it. First, the coupon rate, and the coupon is 5.250, so 5.250. Or we could have, I typed that in, but I could have also just copied it or done an equal, except formatting. The bid price, so that's the 120.9453. The asked price is 121.0078. And then the change from the day before, 0.4063. What we want to know is what the bid price is in dollars then. So what is the dollar bid for a $1,000 par bond? So remember when I said in the lecture and in the book that we take the bid price and we need to move the decimal one place or take it times 10 to get the dollar amount. So times 10, that tells us that the current price is $1,209.45. And then we want to know what the previous day price is. Well, that is today's ask price minus the change. And then in dollar amounts, we take that number times 10. So today, the bid price is $1,209, and yesterday it was $1,206. Okay, in this example, we're looking at zero coupon bonds with a par value of 10,000 and 13 years to maturity. So remember that zero coupon bonds, they accumulate interest during their lifetime and then pay out at maturity, but they don't pay any regular interest rate payments like a regular bond does. So we're going to use our price formula. So much like we used in example 1, I believe it is. So we use our price formula, and we want the settlement date, maturity date, the rate. So that's the rate of the bond, the coupon rate. The yield is the yield to maturity. The redemption is this face value percentage. And then the number of coupons a year, the frequency. So we want a 2 for semi-annual. Our basis defaults to 0. We're going to close our parentheses for the price formula. And then remember, because that returns our price per $100 of the face value, to then get the actual full dollar amount, we want to take 100 times or divide it by 100 times the par value. So we get a price of $5,466.58 for this zero coupon bond that is going to be valued at $10,000 in 13 years. In this example, we have a $2,000 par value bond outstanding with a coupon rate of 3.8% paid semi-annually. We have 13 years to maturity, and the yield to maturity of the bond is 4.9%. And we want to do the price formula. The main difference with this example from previous examples where we use the price formula is that the table isn't filled out for you. So we need to do that ourselves. So we know coupon rate is 3.8, coupons per year are 2. The face value, remember that's shown as a percentage, so it's 100. Our yield to maturity percent is 4.9 from our information. The par value of the bond is 2,000. And the only thing we need to put in are settlement dates and maturity dates. So remember when I said in the lecture, and if you read the chapter, that Excel really doesn't care what those dates are. The biggest thing is that they have to be 13 years apart for Excel to return the correct formula. So in order to do that, we just, a lot of the times, like the textbook said, we just default to January 1st, 2000 and January 1st, the number of years in the future that we need. In this case, it's a 13-year bond, or 13 years until maturity. We then use our price formula, just like we have in previous examples. So our settlement date, maturity date, our coupon rate, the yield, the face value redemption, the frequency of coupons per year, a default basis of 0, and then we want to divide that by 100 times the par value. And we get a current price of $1,790.31. This last example is asking us to compare two bonds. So they both have 5.8% coupons, they both make semi-annual payments, and they are both priced at par value. Bond Bill has 5 years to maturity, and Bond Ted has 25 years to maturity. So we want to know then what happens to our prices. One, if the interest rates rise, and one, if the interest rates fall. So we're going to do some calculations looking at if the interest rates rise and if the interest rates fall. So the first thing we want to do is know the price of the two bonds. So we're going to look at what is the price if our interest rate rises by 2%. So we're going to take 10 times the price, and this 10 times the price is equal to that. It has the same effect as the divided by 100 times the par. We need the settlement dates, and we're doing bill, so that's our 5-year bond, settlement, maturity, then our coupon rate, and the yield is our coupon rate plus the change in interest rate of 2%. So plus this addition of 2% interest. And then, so that's our yield. Now we need the redemption. So that's the percentage par. And then the number of coupons per year and our basis default of 0. So we get a price of $918.49 for bill. The formula for TED is exactly the same, except that we have 25 years. So our settlement date, maturity date, the coupon rate, and then the yield is the coupon rate plus 2% because it grows 2%. Our redemption is 100. The frequency is 2 times a year, and our basis defaults at 0. So then we get that the price of TED is $781.45. It has a longer time to maturity, so we knew that it would be less. So then we're going to look at what is the percentage change. So the for a $1,000 par value, so we're going to take the price divided by we want the price minus the original par, which is 1,000, and then we want that shown as a percentage. So price minus 1,000, and we'll put parentheses around that, and then divided by 1,000. We want that shown as a percentage. And then the same with TED. We have the price of TED minus 1,000 divided by 1,000. So the change in TED is a drop of 21.86%, and the change in VIL is a drop of negative 18.15%. So all else the same, the longer the maturity of the bond, the greater its price sensitivity to changes in interest rates. And so now we're going to look at what is the price at different yield to maturity. And so this is still that same price formula. So do 10 times price. And then we want settlement. And here's the thing, so we can copy and paste all of these formulas. We want to lock everything but the yield to maturity. So we're going to lock every cell. So the maturity date. Maturity, lock that. We want our coupon rate. We want that to be locked. Then our yield to maturity is from this table here. That's the only cell we're not going to lock because we're going to copy that formula down. The redemption is 100, and we are going to lock that cell. The number of coupons per year, semi-annual, and I'm going to lock that cell also. And then we'll copy the price down, and it shows how the price changes based on market changes. We would do the same thing with TED. Settlement, maturity, rate, yield, redemption, coupons. And lock everything but the yield to maturity cell and copy that down.